we are combining some basic mathematics with some basic optics and finishing up with this fun illusion that we have here, although it doesn't really look like an illusion. But we're not going to start here. We're going to start over there. It turns out there are a lot of times in life where you might want to take light that's coming in fairly flat and you want to focus it down to a really small point. And you could do that with a lens, for example, but you can also do that with a mirror. And sometimes you'd rather do it with a mirror than with a lens. Maybe we'll talk about that. And it turned out that the shape that's perfect for that is a mathematical form called a parabola. So something like y goes like x squared. And as shown in this diagram, with a parabola, if you have parallel rays coming in, all of those will bounce off the parabola and they'll all come to the exact same point, the so-called focal point of that mirror. And so we can use that, for example, also in things that aren't opticsy, even like a parabolic dish mic that they use at sporting events, something like that, where they can take all the sound coming from far away and focus it right onto the microphone that they have. So what we have here is a big parabola, and right in the focus of it, we have a match that's over here. And on this other side, we have another thing that's just like this, but instead, in the focal point, we have a very bright arc lamp that I'm going to light up, and that light is then going to come between the two, in this sort of parallel rays between the two, hit this, and then be focused down right on that match. And I'm going to get that started right now. This is basically the same thing as we had on the receiving side over there. This is going to be the transmitter. I've got these two electrodes that I'm going to run a very high current through. It's going to arc really, really brightly. This is in the focal point of this mirror, this parabolic mirror, and that's going to send out these parallel rays out this way that are then collected on the other side and then hopefully focused out onto the match. So we can just get that started just by bringing these together. It's going to be very, very bright. Bring these together and we're pulling them apart.
That's right.
Try not to look directly at it. Okay, so now we're taking all of that light, which is coming kind of in these parallel rays. Out here, it's not really very hot, but because it's all getting focused down right on that small point, at the tip of the match, we can see it's already starting to smoke.
Yes.
Awesome. Okay, an example of transferring energy using pair of parabolic mirrors. Okay, so now we're going to combine the thing we just did. So what I have here is basically two of what we had over there. So I have a bottom parabolic mirror and a top parabolic mirror. And as shown in this diagram, I actually have an object that's sitting at the bottom of this whole thing. And the rays from that come up, and then they bounce. They're in the focal plane of the top one. They bounce straight down. Then they hit the bottom one, and then they come to a focus in the focal plane of the bottom parabolic mirror, which is right there. And so we have this object which looks like it's a real thing there, but really there's nothing there at all. It's completely not there. In fact, the object is way down on the inside of this
thing. That even
thing.
got me when you reached in. It's just like...
Yeah, it's pretty amazing. Okay, that's it. Thanks.